In a previous video, we solved this system of equations, or this AX equals B. We solved it by Gaussian elimination and then by Gauss-Jordan elimination. And we ended up getting this final augmented matrix. In this case, we could just read off the solution. And we got exactly one solution. Even though it's three variables, we call that one solution. And we could just read it off from this matrix is in reduced row echelon form. Let's see what else can happen. Let's say we got this in reduced row echelon form after doing Gauss-Jordan elimination. Well, the top row says that x1 equals 7. The second row says x2 equals minus 1. All this bottom row says is 0 equals 0. What's x3? Can be anything. We call it a free variable. We end up getting infinite solutions. In every solution, x1 is 7 and x2 is minus 1, but x3 could be anything. We'll just say it's some t, and t can be anything. We always like the x stuff on the left and non-x stuff on the right, either numbers or other letters. We don't express any x in terms of other x's, or else we haven't really solved it, have we? That's what we started with. Anyway, so here's an answer, an infinite number of solutions. So the first example, we had exactly one solution. In this case, we have an infinite number of solutions. What about this guy? This is in reduced row echelon form, right? There's no row of all zeros. There's a pivot. There's a pivot. They're both ones. Here's a pivot column, all zeros where it's not a pivot. Here's another pivot column, zeros where it's not a pivot. It's in reduced row echelon form. All the equations say, well, this guy says x, let's see, 1, 2, 3, 4, 5. x5 equals 4. This top equation says, well, there's some relationship between x3 and x4. In fact, it's this. So we could solve, say, for x3 in terms of x4. And here's a way to write the solution. I'm going to get ahead of myself a little bit. This guy has two pivots, two pivot columns. The non-pivot columns, 1, 2, 3, correspond to the free variables. So I had 5, the A part had n columns, 1, 2, 3, 4, 5. I had 2 pivots. That left me 3 free variables. We'll get into this later. But here's how you would write a solution in this case. x1 and x2 were totally free. We'll just call them t and u. x3 dependent on x4. We'll say x4 is free. We'll call it v. So anyway, here's how we would write those solutions. Another case of infinite solutions, but 3 free variables, not just one like the previous case. And here's a third possibility. Let's say you got this after Gauss-Jordan elimination. Well, looking at the whole matrix, including the right side, it's in reduced row echelon form. No all zero rows, all pivots are ones. I could have made these guys zeros, so it's not technically in reduced row echelon form. But even as is, even before I would eliminate these two guys, what does this say? It tells me 0, when I take it back to a scalar equation, it says 0 equals 1. That's impossible. It's an inconsistency. This system is inconsistent. It has no solution. It leads to a conflict. So those are the 3 possibilities. You could get exactly one solution, infinite number, or no solution. And we'll talk about Is there a way to tell this ahead of time or without trying to solve it? And we're going to have to discuss rank. And when we get to rank, you need to know all about linear independence and row spaces and spans and dimensions and bases. So if you're not up to speed on that, you need to go back to my chapter 1. We'll save rank for the next video.